6.5 Operation Radical Expressions. What's the difference between this lesson and the last one? Life isn't easy. That's the difference. The last lesson, it was all nice and everything factored out evenly. Not anymore. So now we're going to have stuff like radical 80. You have to break it down. So the way I like to do it is start small. So I go like, what smallest thing divides 80? So 2, 2 and 40. Then I just go 2 and 20, and 2 and 10, and 2 and 5. Now this is square root, so it's a 2, so you need pairs. So a pair of 2's, a pair of 2's, and then that 5's left alone. Anything that comes out gets multiplied, so there's a 2 on the outside from this one, there's a 2 on the outside from this one, we're going to multiply those, and the rad 5 stays inside. So it's 4 rad 5. So to break those down like we showed know how to do. But even more importantly, how are we going to do variables? So let's say I give you cube root of x to the 10th power. Right, that does not divide evenly. Like before we just divided it. Like when the last time I gave you, what's the cube root of x to the 6? You just go 6 divided by 2 is x squared. Not anymore. But we're going to do it the same way. We're going to divide. So we're going to go 10 divided by 3. If you do that correctly, you get 3 remainder 1. The remainder is the leftover. It's like the 5. It stays inside. So this is going to have this. We're going to have x cubed on the outside, because 3 of them came out. And we're still going to be left with an x on the inside. So that's how we're going to do variables. You still divide it, just like we did before. Power divided by the root. Power divided by the root. If there's a remainder, though, that stays inside. That's a key thing. If there's a remainder, it stays inside. The whole number comes out. So let's do some examples. So again, we're going to break this up. So it's rad 12, square root of 6, and the square root of d3. Again, you don't have to actually write it, but in your head you want to do it. 12, we're going to break that down. That's 2 and 6, 2 and 3. Pair of 2's, so that comes out. I get 2 and radical 3. You need space for the variables. And then we're doing the variables. So this is the 2. 6 divided by 2 is c squared. Right, I have no remainder there. Ooh, sorry. 6 divided by 2 is 3 remainder 0. So there's 3 c's on the outside, nothing on the inside. d3, again divided by 2. 3 divided by 2 is 1 remainder 1. So we're going to have 1d on the outside, and there's 1d left over on the inside because of the remainder. And that's my answer. Let's do the same thing with this one. Cube root of 27, that's just 3. And then we're going to have cube root of y 12. And the cube root of z7. I'll write that 3 down here, a little space. So 12 divided by 3 is 4, so y4 on the outside. Then here we go, 7 divided by 3. That is 2 remainder 1. So we're going to have 2 z's on the outside, and then the 1 on the inside. Don't forget to put a cube root there, because it is a cube root. That's the answer. So again, all we're going to do is like what we normally do. What multiply by itself 3 times equals 27. Divide the power by the root, divide the power by the root. If there's a remainder, it stays on the inside. Remainder stays on the inside. Put more just to practice. Square root of 36 is 6. Square root of a, now so look at this one. Let's break that down. This is a 2, 1. 1 does not divide by 2, right? There's not enough to come out, so that just stays on the inside. 4a. b4, 4 divided by 2 is 2, so b squared. 5, c5, 5 divided by 2 is 2 remainder 1. So 2 c's on the outside, 1 on the inside. Right, so again, let's go over that one again. So square root of 36 is 6. A has a power of 1. 1 can't divide by 2, so that just stays inside. 4 divided by 2 is 2, so it goes on the outside. And then 5 divided by 2 is 2 remainder 1. So 2 on the outside, 1 on the inside. Over here, let's break it up just so we can see a little better. Square root of 144 is 12, that's easy. 7 divided by, remember, I'll show you it's a 2. So 7 divided by 2 is 3 remainder 1. So 3 x's on the outside, 1 x on the inside. 5 divided by 2 is 2 remainder 1. So 2 y's on the outside, 1 on the inside. And that's how you break it down. So let's talk about how we rationalize the denominator. Okay, so this is the thing, I've talked about this before, but we don't really care anymore. So if I give you 3 over rad 2, that's fine. I'm fine with that. That's good. AP Calc and IB treat it that way. Some books you won't see that as an answer, so if you want to rationalize it, so remember the way we rationalize is you multiply by the denominator. So this is the rad 2. Multiply both on top by the denominator, you get 3 rad 2 on top. Rad 2 times rad 2 is rad 4, also known as 2. So that's how you rationalize. Multiply both the top and bottom by the denominator. There's one issue though. The issue is, what if I give you this? Over the, let's say the 4th root of 2. Well, if we multiply both top and bottom by the denominator, we're going to have a problem here. Look what happens on the bottom. On the bottom I get the 4th root of 2 squared. That doesn't simplify. So it's no good. If the power is more than 4, you got to make it add up to be 4. So instead of just multiplying by 4th root of 2, which gives you a total of 2, you got to, this has the power of 1. You got to make them match up to match that power. So the power here should be 3. So on the bottom I'm going to get 2 to the first times 2 cubed, which is 2 to the 4th. And on top I'm going to get 5 to the 4th root of 2 cubed. Right here they cancel out, so it just means I get 5 to the 4th root of 2 cubed. That's what that says. All over 2. Again, we'll practice on the bottom, but that's the idea. So that's how you rationalize the bottom when it's a number other than 4, which is to be more interesting. This, again, I really don't care. That's fine. But that is how you rationalize. We're going to use it. I'm going to do a little bit of that. But that's how you rationalize when the numbers don't match. Which I think is more interesting, but again, I also don't really care. Like, AP, it's not an issue in AP Calc and IB Math. Anyway, this one, again, if they want me to rationalize it, just multiply both top and bottom by the bottom. Let's see if it works out. Again, I'm fine with this. Like, that's a good answer, but if they want me to rationalize it, I'll rationalize it. So I'm going to get A9 b to the 5th all over square root of b to the 10th. You can simplify both of these. Like, remember it's the 2. 9 divided by 2 is A4 with a remainder of 1. 5 divided by 2 is b squared with a remainder of 1. On the bottom, 10 divided by 2 is b to the 5th. And, to the 5th. And these actually reduce. So my answer would actually be A4, AB, B cubed. So again, I'm actually fine with this, but that's the rationalized version. That's air quotes. Next one, because that one actually interests me. Because that one's a little more interesting to me. So we're going to separate it. It's the 5th root of 3 and the 5th root of 4y. Now again, if you want to rationalize this, I need the powers here to match up to be 5, because I need them to cancel out. So I'm going to multiply both top and bottom by the 5th root of 4 cubed and y cubed. That we can make them match to get 5. 4. I can do math. 4 times 1 is 5. 4 times 1 times is 5. Sitting at the top, right, I need 4 to the 4th and y to the 4th. So on top you're going to get 5th root of 3 times 4 to the 4th times y to the 4th. All over, they're going to cancel out. You're going to get 4y. And then you can simplify that. Again, it seems pointless to me. I feel like we already did that one. That's the same thing. We're going to move on because I really don't care. So that's interesting. Operations radicals. So we're going to talk about how to simplify radicals this way. So when you multiply radicals, you multiply the outside by the outside. So 15. And you multiply the inside by the inside. So radical 16x squared. Then we can reduce it. Square root of 16 is 4. And square root of x is x. So root of x squared is x. So you get 60x. Alright, so again, just multiply outside by outside, inside by inside, and from there you can simplify it. Same thing here. Multiply outside by outside, so I get 6 on the outside. And then I'll multiply the inside by the inside. 8 times 2 is 16. Y3, Y5 is Y8. X8, sorry. Y2, Y2 is Y4. Now we can simplify it. There's a 6 on the outside. 4th root of 16 is 2. X to the 8th divided by 4 is x to the 4th. X is x squared, sorry. And 4 divided by 4 is 1. So we get 12x squared y. Over here we do the same idea. Just multiply them, you get 4th root of 81, x to the 4th, y to the 4th. Well, 4th root of 81 is 3, and then those divide evenly, so x and y. So that's the idea. So it's just, the main thing here is when you multiply radicals, inside by radical times radical, and outside number times outside number. That's the way it goes. Let's talk about how to add radical expressions. Very similar to adding variables, right? If I give you like something like this, the only ones you can add are 3x and 2x that are exactly the same. They both have an x, so you get 5x plus 4y plus 2x squared. Right? I can't add the x squared with the x because they're different. You can only add the ones that are exactly the same. The same thing goes for when you want to add radical expressions. Rad 3b and 4 rad 3b are the same because these are both 3b. But once I change the power, they're not the same. If I change the number inside of it, they're not the same. They have to be exactly the same, just like how x and x have to be added, but not x squared. So that's the idea. Break it down, and then the ones that are exactly the same, those are the ones you could add. So let's break them down. So I got to break down 8 first. Remember, it's 2 and 4, and then 2 and 2. So you get a pair, comes out. Remember, when there's something on the outside of it, you multiply. So it's 4 times 2. So 8 rad 2. Right, so pair of 2's makes the 2 on the outside. There's already 2 left. There's a 2 left over. 50, that's 2 times 25. I know the square root of 25 is just 5. So that comes out. There's already 3 there. You multiply them. And you're left with the 2. Now these are exactly the same. You can add them up. 23 rad 2. Same thing over here. 32 is 2 times 16. Square root of 16 is 4. So I get 20 rad 2. 27 is 3 times 9. Square root of 9 is 3. So I just get 3 rad 3. And then 75 is 3 times 25. Square root of 25 is 5. There's already a 2 out there, so you multiply them. You get 10 rad 3. So again, here, only ones I get out are the ones that are exactly alike. And this is like I'm adding variables. 3 plus 10 is 13 rad 3. One more of this type. So we'll just break it down. Let's go a little faster now. 4 times 10, square root of 4 is 2. 10 doesn't break down to anything. It's 2 and 5, so no pairs. 28, 2 and 14, 2 and 7. So a pair of 2's comes out. 6 rad 7. 200, that's 2 times 100. Square root of 100 is 10. So minus 10 rad 2. Hey, these are all different. Can't do anything. There you go. Just simplified it. Now let's multiply radicals. Similar idea. All we do is distribute. So I'm going to multiply this 4 by both of them. 4 times 3 rad 3. Remember, on this case, the 4 can only be multiplied by the 3 because they're both on the outside. They're both not radicals. So I get 12 rad 3. Then 4 gets multiplied by 4 rad 5. I can only multiply the 4 by the 4. They're both on the outside. So we get that part done. And then we move on to the next one. 2 rad 5. And here, 2 times 3 is 6. And then the radicals can multiply by the radicals. You get 15. And on this one, 2 times 4 is 8. And radical times radical is radical 25. I know the square root of 25 is 5. So this is actually just going to be 40. I could add like terms right here, and I get 22 rad 5. And then 12 rad 3. And that's it. They're all different. This is the same thing. Another one. Let's do it real quick. So that's going to be 12 rad 15. That's going to be 24 rad 6. Then the next one. That's going to be negative 10 rad 5. And that's going to be negative 20 rad 2. I could add these two. No, I can't. And I see the 1 right there. So they're all different. And there you go. You're done with that one. Okay, next. Talk about many times how it's gonna come back. Now they want us to rationalize these denominators. The way we do that is you have to use a conjugate. So remember, don't forget what the conjugate is. If you have a plus b, you multiply by a minus b. You just switch them other terms. That gives you a perfect square. So now if you multiply these, you're gonna get a squared minus b squared. So if I want to multiply the conjugate at the bottom here, I'm just change the middle sign. On top, you just distribute. You get 5 rad 2 minus 15. On the bottom, you can actually go through the whole process. But again, if you're multiplying a plus b times a minus b, you're going to get a squared minus b squared. So if you want to save like 10, 20 seconds, you just go, okay, rad 2 squared is 2. And then minus 3 squared is 9. So I get 5 rad 2 minus 15 over negative 7. So again, if you want to save yourself like 10 seconds, you can do that. If not, you just multiply it out and they'll cancel out. You get this. Same thing with the next one. Again, you want to rationalize the denominator, so we're just multiply with the conjugate. So all we're going to do is change the middle sign. The bottom is the easy part because we know it's going to multiply to get a squared minus b squared. So it's going to be 4 minus 9 again. I guess 2 minus 9 again. Same thing. Top, you have to actually go through the trouble of actually multiplying it. So you can be like 4 rad 2 plus 12. And then rad 2 times rad 2 is 2. And that's going to be 3 rad 2. Rad 2 times 3. Add up like terms. 14, 7. So I get 14 plus 7 rad 2. All over negative 7. You think I'm done, but that actually simplifies, right? These all divide by negative 7. So divide everything by negative 7. So you get negative 2 plus, actually minus rad 2. If you're not sure, look at it. Just on top, divide by 7. Factor out the 7. Now these cancel going to be multiplied. And you get, I didn't factor it out because I suck. And you get 2 plus rad 2 over negative 1, which gets you that. So again, as long as they all can be divided by 7, you can divide them. You can divide by a number. Not the radical. Radical is separate. There's another thing, by the way. I notice people do this. You can't do anything here. The 2's don't cancel out. That's inside the radical. It's locked in. So that cannot mess with that. It's only about these two. So nothing can happen here. So keep that in mind. Almost done. Let's say simplify expression if b is an even number. It's the last thing we're going to do today. So before I do that, let's go back to what we did before. Let's do like the cube root of a to the 15th power. Right? The way we did this is we caught the power and divided by the root. So this was a15 divided by 3, which gave me a to the 5th. This is the same thing. Don't let the variable scare you. You take the power divided by the root. So a4b divided by b, which gives you a4. Same thing will happen here, right? a3b power divided by the root. The b's will cancel. A cubed. There we go. That's the lesson.